Welcome. In this presentation, we are going to solve one example in linear programming problem. Solution of LPP by graphical method. Example, solve the following LPP by graphical method. The example is minimize z is equal to 4x plus 2y subject to 3x plus y greater than or equal to 27, x plus y greater than or equal to 21, x plus 2y greater than or equal to 30, x is greater than or equal to 0, y is greater than or equal to 0. Now in this example, x and y are decision variables. Z is equal to 4x plus 2y is objective function which is to be minimized. 3x plus y greater than or equal to 27, x plus y greater than or equal to 21, x plus 2y greater than or equal to 30 are constraints. And the last but not least, x is greater than or equal to 0 and y is greater than or equal to 0 are non-negativity constraints. Now since x is greater than 0, y is greater than 0, the solution is in first quadrant and there are three constraints. So we have to draw three lines and decide which plane, either origin side or non-origin side of the line is solution set of given inequation. We substitute coordinates of origin in this inequation. If this inequation gets satisfied by the coordinates of origin, then origin side half plane of the line is the solution set, otherwise non-origin side. So let us solve this example. We are going to solve this example by corner point method. To draw the solution sets of these inequations, 3x plus y greater than or equal to 27, x plus y greater than or equal to 21, x plus 2y greater than or equal to 30, we draw lines 3x plus y equal to 27, x plus y equal to 21 and x plus 2y equal to 30. Now to draw these lines, we prepare one table in which we find x-intercept and y-intercept of each line to make easy to draw the line. So we make this table. First column is for name of the line L1, L2, L3. Second column equation of the line, then intercept. We find x and y intercept for each line, then sign. The inequality sign greater than or equal to or less than or equal to. In this case, all the three constraints, the sign is greater than or equal to. And then we decide the solution set half plane is solution set of that inequation. Now first equation is 3x plus y equal to 9. Now to find x-intercept, we substitute y is equal to 0. So we get 3x is equal to 27, x is equal to 9. To find y-intercept, we substitute x is equal to 0. So we get y is equal to 27. Similarly for second line and third line. Now we consider this sign of inequation. All the three inequations are having greater than or equal to sign. So if we substitute coordinates of origin here, 0, 0. So 3 into 0, 0 plus 0. And the sign is greater than or equal to. So 0 is not greater than or equal to 27. Therefore, origin is not satisfying this inequation. So the solution set of the first inequation is non-origin side of this line L1. Similarly for second and third, non-origin side of L2 and non-origin side of L3 is solution set of second and third inequation. Now x is greater than 0 and y is greater than 0. The common solution lies only in the first quadrant. Okay. Now we draw first x-axis, then y-axis. Then while taking scale, we consider these values. Here x-intercept is 9, here 21, here 30. So on x-axis we require up to 30. So you considering these values of x-intercept, we take the scale. Similarly for y, Here y-intercept is 27, here 21, and here 15. So considering these values of y-intercept, we consider the scale on y-axis. Here we consider this scale 5, 10, 15, 20 up to 35 on x-axis. Similarly on y-axis 5, 10, 15, 20, 25 and so on. Okay. Now we draw the first line. Here x-intercept is 9. So we get this point 9, 0. Y-intercept is 27. So on y-axis we get this point 0, 27 here. Okay. Now we draw this line L1. Okay. Now non-origin side of this line is the solution set. Now consider this line. Here there is origin. So due to this line L1, this plane get divided into two half planes. One half plane containing origin and this half plane. It is not origin is not there. So this half plane, origin side half plane, and this half plane is non-origin side half plane. So here non-origin side half plane is solution set of given inequation, first inequation. Okay. So we denote this solution set of the first inequation 3x plus y greater than or equal to 27. This shaded region is solution set of first inequation. Now second line, here x-intercept is 21, y-intercept is also 21. So here we have this point 21, here we have this point 21, 0, and here we have 0, 21. Now we join these 2 points and we draw this line L2. Now here non-origin side of this line is solution set of this second inequation. So we denote the solution set by this region, this greenish region. Now third line, x plus 2y equal to 30. X-intercept is 30. Here we denote this point 30, 0. Y-intercept is 15. So 0, 15, this point. Now we join these 2 points and we draw line L3. Now here non-origin side of L3 is solution set of the third inequation. Okay. So all the points on L3 here greater than or equal to sign is there. So all the points on L3 and all the sides which are on non-origin side of this line. So we denote this solution set of third inequation by this reddish region. So we denote solution sets of all the 3 inequations. Now we want to find common solution set, common region of all the 3 inequations. Okay. So if we consider the common region, which is non-origin side of L1, non-origin side of L2 and non-origin side of L3, we get this region, this blue region is common solution of all the 3 inequations. Now we are solving this example by corner point method. So if you observe, this common solution set is not bounded, but we have the corner points of this solution set here 1, 2, 3, 4. If we observe this region, this part, we get 1, 2, 3, 4. These are 4 corner points of this this solution set, or this region is known as feasible region. Now solution, that means minimum value of z is at least one of the corner points, and since this problem is of minimization, we get solution at least one of these 4 corner points. So we have to find first coordinates of these 4 corner points. Here we have coordinates of 1, 2, 3 and 4. These 4 are corner points. Now we have coordinates of this point A 0, 27. We have coordinates of this point D 30, 0. Now these 2 points, we consider this point as B, this point as C. We have to find coordinates of these 2 points. Now if you observe this point is point of intersection of line L1 and line L2. So here is equation of line L1 3x plus y equal to 21 and equation of L2 x plus y equal to 21. We solve these 2 equations of L1 and L2 and we find coordinates of this point of intersection of L1 and L2. So if we subtract this second equation of L2 from L1, y get cancelled, 3x minus x we get 2x, 27 minus 21, we get 6. So 2x is equal to 6, x is equal to 3. We get x coordinate 3, substituting 3 in equation of this line L2. 3 plus y equal to 21, we get y is equal to 21 minus 3, we get 18. So we get coordinates of this point B 3, 18, x coordinate 3, y coordinate 18. Similarly, this point is point of intersection of this line L2 and L3. So this point is point of intersection of L2 and L3. So to find coordinates of this point, we solve equations of line L2 and L3. Here x plus y equal to 21, x plus 2y equal to 30. So solving these two equations, we get coordinates of this point 12, 9. We denote this point by C. So now we have coordinates of all the corner points of this visible region. Okay. So let us move to the next slide. In this slide, this table, we prepare for this table, then we draw this graph, then we find the coordinates and denote them on this graph. So here we find the coordinates of point B, which is point of intersection of L1 and L2. We solve equations of lines L1 and L2. These two equations, 3x plus y equal to 27, x plus y equal to 21, subtracting, we get value of x is equal to 3. Then from equation 2, we get value of y 18. Okay. So coordinates of point B are 3, 18. Similarly, we find coordinates of point C. Now point C is point of intersection of L2 and L3. So we have to consider equations of L2 and L3, that is x plus y equal to 21, equation of L2, x plus 2y equal to 30, equation of line L3. So now subtracting these two, we get x minus x0, y minus 2y minus y, 21 minus 30, we get minus 9. So we get y is equal to 9. Substituting y is equal to 9 in equation of L2, we get x plus 9 equal to 21, therefore x is equal to 12. So we get coordinates of this point 12, 9. We denote this point by C. So we have denoted these 2 points in the graph, B 3, 18, C 12, 9. So now the common shaded region is the visible region with vertices A 0, 27, B 3, 18, C 12, 9, D 30, 0. Now at these 4 points, we find value of Z, and out of these 4 values of Z, which is minimum, that is the required solution. So we will find value of Z at these 4 corner points of the visible region. So we prepare a table. First column, vertices of visible region, x vertex, x coordinate and y coordinate, and value of objective function Z is equal to 4x plus 2y at xy. Only we have to substitute value of x coordinate in place of x, value of y coordinate in place of y, and we find value of Z. Here first corner point A 0, 27. So we get 4 into 0 plus 2 into 27 equal to 54. Value of Z at this corner point B 3, 18. 4 into 3 plus 2 into 18 equal to 48. Value of Z at C 12, 9. 4 into 12 plus 2 into 9 equal to 66. Similarly, value of Z at this corner point D is 120. Now, since the problem is to minimize Z, we find minimum value of these 4 minimum value out of these 4 values of Z. So 54, 48, 66 and 120. 48 is the minimum value. So here we get for from the table, minimum value of Z is equal to 48, which occurs at B 3, 18. That is when x is equal to 3, y is equal to 18. So solution of the LPP is x is equal to 3, y is equal to 18, and at this point we get minimum value of objective function Z is equal to 48. Okay, so thank you for watching.